about to say good morning to everybody, but actually, no, it's afternoon now, isn't it? Good afternoon. We'll have a few more minutes. I know we're technically supposed to be starting now, but we don't have many people here yet, so we will see. Good afternoon, Kaylee. Oh, no, you're now leaving. Okay. Afternoon, Erica. Oh, Kaylee, you're back. Lovely. And so you popped up for a minute and then you disappeared again. Right, well, wait a few more minutes because I know people have come out of the last session, so we'll give it a few more minutes before we get started. Have you two had a little bit of an input into the form? So which chemist do you think has had the most influence? So if you go to the post and then be able to choose which chemist do you think has been the most influential? Oh, ladies, it's just you two still at the moment. This is going to be a really quiet one. I think everybody probably came to the last one. I've literally done two back to back. We had loads in that first session. So who knows? It might just be you two. This is going to be the smallest little individual taste day session ever. The first one was like 90 odd people, and now there's you two. So that's lovely. If it is going to remain you two, if you wanted to obviously unmute, feel free on this front. Because it's going to be like probably like just a chat, isn't it, between the three of us? Oh, Erica Mendeleev. Why Mendeleev? And Kaylee, Erica's put her thoughts on the line. So what do you reckon? This is now a case of how quickly can we type? Oh, hang on, I've just accidentally clicked. Yeah, no, fair point there, Erica. Yeah, absolutely, because everything we do, obviously, we still use the periodic table, don't we? We have a look at those atoms. So just the whole fact they're structured tells us so much. So yeah, I like that. Oh, Kaylee, you're sitting on the fence again, my lovely. Go on, just plump for one. Yeah, Erica's just gone. Mendeleev covers everything. Too many options. What do you want me to do? Give you three? I think we'd still have got too many options. Can't choose. I'll tell you what, you can have if need be. Yeah, that would be the only way it's going to work, isn't it? You've got to the end of this session to make your mind up, and then you are just going to have to click on one, and that'll be it. That'll be the choice made. Whether you totally believe in that or not, you just have to go for it. Right, well, my lovelies, we are going to get started because it genuinely is just you two. So this is awesome. We are recording this. This is going to be the funniest sort of transition video ever when there's me chatting to you two quite happily. But well, obviously you want to know about chemistry and what we're going to be doing. So in chemistry, we are going to be building on so many things that you've already done. And that's the key thing with this. It's, all the knowledge that you've got at GCSE, and then build upon that lots more. So the key thing to remember is that we don't exist without chemistry. I know there's all these arguments that every mathematician, every physicist will quite happily turn around and say, no, everything, has to only be, or everything's only here because of the laws of physics and because of maths and the patterns in things. But actually, it's all very well having these laws and patterns in things, but you actually then have to have things to be able to make up stuff, which obviously isn't going to include us and all things we have. So, chemistry is essential in the fact that regardless of all the forces and the principles in the world, if you don't have things to attach them to, you've got nothing. And then the other thing to remember is that chemistry, of course, is just about the electrons. So I know we talk about atoms, but really it's the electrons. What are the electrons doing? How are they moving? Are they bonding? Are they breaking up? Are they shifting to a higher energy level? What is it that they're doing? It's like a whole EastEnders saga of just these electrons. They have little relationships and they do certain things, and that causes stuff to happen. And as the screen says, and hopefully you can see the screen because I think I'm sharing it with you. It says so on the screen. But seriously, chemistry is essential. Without the bonding, we wouldn't have anything. The world would fall apart. We would have nothing. So that is a really key phrase on that front. So you obviously have come along thinking, what do we do in chemistry? And this obviously is coming from myself. I know chemistry teachers, but it is fun. It is great fun to be able to figure out what on earth is going on. We've got this practical that's going on. We've got some colour change. We might have some temperature change. Why is it doing that? So we have the fun aspect of being able to do the practical aspect, but also the challenging side of it. Because, I'm going to make no bones to this. Chemistry is a challenging subject. I'm not going to say it's hard because nothing is ever insurmountable. It's just a case of how you're going to work through it. But it is challenging. It's not one of these things where you just give everything a plate. You've got to work for it. You've got to start thinking and getting your brain to go for it. Because at the end of the day, we're looking at things you can't even see under an electron microscope. We can see atoms under electron microscopes, but actually we're looking at the subatomic particles. We're looking at the electrons, and we can't see those. So we have to have a lot in our heads. There's a lot of conceptual stuff that we've got to sort of get to grips with. And when you get to have that sort of idea and you go, I get it. That challenge that has been bugging you've been working on. When you get that light bulb moment, it's like, oh yeah, this is good. This is really good. And you can then start seeing the logic and how it fits with other things. And that's where the challenge becomes fun as well. So it's not just the practical, it's the thinking that becomes fun. So of course, it broadens your understanding of everything around you. You can start going, oh yeah, I know why that works. I know how that exists. I know why we have this, and this, and I know why you shouldn't be putting, bleach down the toilet and then weeing on it because you're going to gas yourself out with a load of chlorine, etc. We also have, and this is a massive part of it, we develop a strong skill set. Now, as scientists, we are so sought after by all sorts of employees. And 5% of all university scientists go on into the field of finance. And you might think, well, hang on, they've not done maths in that sense. They've done their science. Why go into finance? We have a chunk going into there because, of course, we're numerate. We can use numbers and manipulate numbers. We have a big chunk of people that go into journalism because you need people who can also write about quite technical things. So the sciences, you need a science journalist. You need somebody on the news that is going to be able to actually do the research behind it, understand it, to write a news article for them to read on the 9 o'clock news. So there's so many other areas that are not just specifically in a lab, but are related to science that scientists go into. And that's because, say, we're numerate, we are literate, we've got to be able to write about what we're looking at, what we're studying. We've also got great oracy skills. We're able to talk about this because a lot of the time, as I said, we're dealing with things that are so conceptual, they're absolutely in our head. And often, if you're floating ideas around your head, you need to talk about it and explain it to somebody else. And that way, you're helping to develop that picture in your own head. As you're putting it across to somebody else, you're sort of formulating that ideas and you're consolidating your vision, and you're helping others develop their understanding as well. So we are good orators. We can speak about what we're doing. We also have got good practical manipulation. We need dexterity. We can hold and clamp a load of things in one clamp stand while doing something else, while stirring something else. And we have got good manual dexterity. So again, that hand-eye coordination, that dexterity is a really useful skill. And then there's just the other side of it in terms of we have logical minds. We tend to be able to analyse and evaluate. We can be critical. So massive load of skills that we're able to offer the world. And that's a great thing from chemistry because we have all of those in abundance. And then, of course, the final thing that people always come into chemistry and go, are we going to blow something up today? Occasionally we do have like little mini explosions, or we have some kind of redox reaction, or something that's just going to go poof, or intentionally. And then, of course, sometimes we have these things happen unintentionally because that's just the nature of it. A reaction will happen. As to how vigorous it is sometimes takes us by surprise, because even if it shouldn't be particularly vigorous, you never know. So chemistry is a good all-round subject to do. So entry requirements, we do ask you to have a grade 6 in your triple science or a 6/7 in your combined science. If you get 6/6 in combined science, then obviously we then will be discussing, looking at it and have conversations with you as to suitability. So it's not the end of the world if you don't get the 7/6, but definitely 6s. We also ask that you get the 6 in maths as well, because we do use an awful lot of maths. Particularly in the second year, where we start looking at logs and we have a lot of rearranging of equations and making sure that you can deal with powers and multiplying negative numbers, etc. So you do have to have a good command of math skills. So I'll just run through a bit of the content, because that's probably what you really actually want to know about. So in year 12, and we say this is the AS level content, we don't do AS levels anymore at the school, but we still use the AS papers as your year 12 mock exam. So this content is still very much relevant to us. Now, in the first year, we have 4 modules, and these link directly to our textbooks that we use as well. So module 1, we do throughout the entire 2 years of the actual course. And this is because it's development of practical skills. So knowing what you're doing, knowing how you're going to do it, knowing what equipment you've got to be able to do it, and then able to actually look at those practicals objectively and be able to go, oh yeah, I can evaluate this, I can be able to talk about precision, and I need to know about accuracy. So we do module 1 literally right from day 1 to your final practical that you're ever going to do. Then module 2, this is one where we actually sort of start the nitty-gritty knowledge aspect of it. And when you start it, you're going, oh, I know all this already, because we obviously start, oh, I nearly knocked my headphones out then. We start from the basis, it's all gone a bit funny. We start from the basis of what you know at GC is a brilliant starting point. Now let's step on from that and expand it some more. So we'll be looking at obviously atomic structure, we'll be looking at moles, we'll be looking at periodic table, we'll be looking at the shapes of atoms and molecular formula, etc. So a lot of module 2 is what you've already done at GC, just ramped up a little bit, and quite a lot of calculations in there. The humble old mole features really heavily at A level, so you've got to start to learn to love your moles. Module 3 is periodic table and energy. And again, you've already come across these within your GCSEs, but we're extending that a lot to a much higher level. And then finally, the organic chemistry. So again, you've done some organic chemistry. Obviously, as triples chemist, you've done that whole module of the C7 of the organic chemistry. So this is just adding even more to that. There's more functional groups that we need to look at. The ones that we look at in the first year, you will be familiar with. The ones that we then look at in the second year, you won't be so familiar with, and that's the, let's say, ramping up to the next level. Now, the papers that you do as your mock exams, these are what we call the breadth in chemistry and the depth in chemistry. They're quite lengthy, but they have multiple choice in there as well as long answer questions. And it's a 50-50 even split when we look at what they're actually worth and how are you working in your year 12. This is the key one, though, for A level, because of course you'll start the course and then you'll do your final exam at the end. It's called a linear exam. So we will do everything and you get examined at it at the end. So you can see there your first 4 units, that's the same as for the first year. And then we've got module 5 and module 6. So in the second year, we only do these 2 modules as the knowledge-based ones, because of course module 1 goes throughout the whole lot. So module 5 is building on more of the physical chemistry. And this is where it gets really quite maths-based as well. So we look at rates of reaction, equilibrium, etc. And then even more organic chemistry and more analytical skills, so looking at spectroscopy. Now, when we have get to the exam period, you actually have 3 exams at the end of the whole course. The first one is this component 01, And this assesses everything to do with periodic table, physical chemistry, inorganic chemistry. So essentially it's modules 1, 2, 3, and 5. Anything that's in those modules can turn up on there. And it's 100 marks. You get a good few hours to do it in. And it's 37% of your total A level. We then do paper 2. And this is your organic and your synthesis and analytical techniques. And this is anything that happens to be in topics 1, 2, 4, and 6. So all questions in those particular modules. And again, you can see it's equal weighting between those first two, because they're your really heavy knowledge ones. So do you know this stuff? Can you understand this information? And then we've got the third paper, and this is unified chemistry. This is what we call a synoptic paper. So you have to know absolutely everything, because they can take questions from all 6 of those modules and they put it into different contexts. So you'll see a question, you'll be like, oh my God, I've never seen that molecule in my life. And that doesn't matter, because you have the information, you have the knowledge that you've learned over 2 years to be able to apply to that situation. So grade boundaries, they're not too bad actually. Usually we're looking sort of 37%-ish for an E grade, and obviously going up by roughly 10% after that. You might just think, oh God, that's quite high. Yeah, it's not on the floor. Although it's a challenging subject, it's not like 5% will get you a grade. You have to actually work for it. And certainly when you want to be getting your A's and A stars, you're going to need to be looking in your 70%. So it is still quite a high grade boundaries actually, Erica. So yeah, it's not easy in that sense. But obviously we guide you through, we teach you all stuff you need to know. We ask you to put in a lot of work as well on this one. Now at the bottom here, we've got the practical endorsement. And this is something I say that we do throughout. So we'll do lots of practicals anyway, but then we have to have some of those are what we call PAGs. And these are your actual assessed practicals. So we've got a set criteria that we have to get through. And we have 12 different sections where we have to choose one practical within each of those 12 sections that you must complete within the 2 years. And you then also have to tick off each one, I say, the different criteria of practical skills. And that could be practical manipulation. So it might be they have to stand there and watch you measure something out. Or it might just be, I look at your results table once you've actually done the practical, and or it might be looking at your calculations, but you get to do a whole load of practicals. And now you have multiple opportunities to actually be able to achieve all those different criteria. And by the end of it, it's either a pass or it's a fail. So it's not written at the end. It's something that is, you're working towards constantly throughout the 2 years of the course. Now, majority of people pass this because, say, we give you enough opportunities to be able to engage with the work, to be able to have enough practice goes doing practical anyway. So you build up the skills before you do the assessed practicals. And even then, we've got 3 chances at each section of practical. So we usually only need to have 2, and we work your way through until you're able to actually be competent. It's all about your practical competency. The only times when people haven't achieved it is if they've had long-term absenteeism and they've just not been there to learn the practical skills. So it's one of those key things that certainly if you want to then go and do sciences at university, the universities do actually say, we would like you to have a pass in the practical endorsement. Obviously, if you're going to something non-science based, they're probably not as worried about it, to be honest with you. But it's a nice thing to be able to turn and say, look, I am competent, I'm safe, I know how to manipulate all this practical equipment, and I can carry out a practical. So that's essentially what it's saying. You have the skills. Okay, so I've just popped up the summary of the content and just have a glance through that. And hopefully you'll be going, oh yeah, I know a lot of that already. And that's the key thing to remember with all this. You have already come across the majority of the work we're going to do. You've just come across it at the beginning levels that we're then going to build upon. I say, chemistry shouldn't be this scary beast. I keep saying, yes, it's challenging, but it shouldn't be scary because you've heard of these things. You know about acids, bases, you know about the electron structure, you know about the bonding, you've heard about hydrocarbons, you've done a bit about reaction rates and equilibrium. So all of these, we've had really good starting points so far with your GCSE, and then we just take it on to the next level. So you're not going to come across anything that you have no knowledge of previously. There'll be things you go, oh, okay, that's a new bit, it's related to that, and I know about that. So I say we do build upon it, and it's like a spiral going round and round. and we add the next new bit each time. So it's still a relatively new course. We've only had it for 5 years. 20% of the exams has got a maths-based content to it. So when you have a look at the papers, you'll be like, oh, actually, yeah, there's a fair few lots of calculations to do. Hence why we asked for that grade 6 in maths. You have got to be comfortable finding your way around a calculator. We've got 15% of the exam papers as well are based on work that you've done in practical. So it'll either be giving you a scenario that you then have to evaluate or analyse, or it might be asking you, how would you do this particular practical? What equipment would you use? Or how would you ensure that you're accurate? Or it might be why would you use this piece of equipment over this piece of equipment? Or it might ask you to explain the process of reflux or crystallization. So there is always going to be some component, and 15% of it that is going to be based around practical. Because at the end of the day, we find most of our stuff out by practical means, or if we're not going to do it, it has already been done in the past in order to get that understanding there in the first place. Key thing now, obviously AS exams, we only use them as mocks. They don't actually count towards your final A-level grade. We use them as diagnostic tools to be able to help you figure out what you do know, what you don't know, what you need to do over the summer between year 12 and year 13, and ready to make sure that you are fully prepped, ready for your A-levels at the end of it. There is different types of questions as well, as I've just popped up from there. We have multiple choice questions as well as the normal sort of short answer questions that you would expect. There are also some longer answer questions as well. So a 6 marker, very, very similar to what you've seen at GCSE. So you get a mixture of all of it. So again, just building up from what you've already been there and done at GCSE. You'll be taught over your 2 years by one of the 3 chemistry teachers, so myself, Mrs. Takali, or Mr. Nawaz. So who knows what the timetable will be, what class you happen to be in, but it will be 2 of the 3 of us, and then also you never know, by the time you get to year 13, there might be staffing changes, who knows, but that's certainly for September who you'll be seeing around. And we always try and make sure you get 2 teachers, and the reason for this is some people prefer one style of teaching and another style of teaching. So in order for you to make sure you get the maximum benefit from this, is if you have 2 teachers, if you're not sure about something with one, you've got the other person there that you can go and talk to and just say, look, can you explain this to me, please? And particularly when we get to revision, I know with certainly Mr. Kali and myself, if she's taught a particular module, I will then revise that module, and we do it vice versa. So that way you get it taught in one particular way, but you get it revisited in the other teacher's way of doing it. So you might find a different way and go, oh yeah, that's how they do it. I like that better. So it just gives you another person, another point of contact to be able to talk to. Right, I've talked for enough, although saying that, I'm still going to be talking. Time for you to do some stuff. So we're going to play a little bit of a game. So you'll need to get yourself a pen and a pencil. So I'll just give you a few minutes while you get that pen and pencil. Okay, if you're both sorted, or oh, there's 3 of us now. Sanjita, I didn't know you popped in. Awesome. The 3 of you, that's fab. Make sure you've got that pen and pencil with you. Right, we're going to be naming that molecule. So what you have to do is, once I've shown you a picture of a molecule, you need to write down its name and its molecular formula. Okay, so we're going to go through them all at the end. So don't put anything into chat. Make sure you put it on your piece of paper. So it literally is, we're going old school here. You know, it's paper and pencil. Pop them down first of all, and then at the very end, we will put stuff into chat. Okay, so no chat, get your hands off that keyboard, get that pencil in your hands. We're going to go through these now. Are we ready then? So this is going to be a tight competition, isn't there? If there's only 3, it's like, oh, this is going to be a bit of a challenge. Right, number 1. Oh no, it did this before. It doesn't like this next slide. Hang on, this is where I have to go back, and it's, there you go. It's decided that it's going to do it now. I think it's got something against this molecule. It's doing that for the last session. So here we go. First molecule, not in chat yet. Write it down on your piece of paper. What is this molecule and what is its chemical formula? hopefully you can remember from using the different modeling kits, or you've seen the pictures of it, that fingers crossed you'll appreciate that the black blobs represent carbon and the white blobs represent hydrogen. Okay, we're gonna move on. Number 2. Bit easy there, look, all labelled. Managed to find one that actually had the elements on it. So, what's the name of this molecule and what's its formula? Number 3 coming up. Nice easy one, that. So what's that molecule and the formula? I think quite nice actually. I think the first 5 are fairly straightforward. It's after that it's going to be a bit trickier. Okay, number 4. What is this one? You should have seen this one in books so many times as you've gone through your key stage 3 and key stage 4. Ready for number 5? There we go. Red ones are oxygen, black one carbon. What is that molecule? Okay, number 6. Those molecule balls, it's supposed to all be black. It's just trying to find pictures where they've all got the same tone. It's a little bit challenging. So they're all supposed to be represented by a black molymod ball. Okay, next one. Looks like a couple of apples on sticks. Number 8, one of my favourite molecules in terms of molymod anyway. So think, what is its name and what is its chemical formula? Okay, next one. This is a little bit of a toughie. I'll give you a bit of help here. That middle yellow ball, that's actually sulfur. So when we have these models, that slightly darker yellowy colour is sulfur. We have a couple that are yellow coloured, one sodium, but this slightly darker one, that is sulfur. So what is that substance? What's that molecule called and what's its formula? And then finally, last one. What is that? Okay, right. We're going to be going through them all one by one. So hopefully we've got number 10 down. Right, here we go. I think we've got, when it comes up, flashes up, they might be in slightly wrong order. So let's go through then. Number 1, pop into chat. What is number 1? So the name and the formula. Awesome, well done. Oh, we've lost an attendee now. Look at that, we were we're missing. It's back to you two again. So yeah, CH4, and it is methane, right? And number two, what's that one going to be? Fab, good stuff. Yeah, well done, Kaylee. It's ammonia, so NH3. Well done, Erica. And you both got the spelling of ammonia right. That is fab. Because when we get into the second year of A level, we look at something called amines and amino acids, and obviously the part that these play in forming the building blocks of life. And amines have one M, and obviously ammonia has two M's. And they're slightly different when we talk about chemistry terms. So if we want to say, we've got I don't know, I think an amine group, we're not looking at an NH3 group. And same with like an amide, we're looking at an NH2. So we have to make sure that our spelling actually does relate to what we're looking at. So ammonia has got that double M when we spell it. Right, number three. What is three? Oh, is that one there? Yeah, fab. Good old sodium chloride. Well done, Kaylee. Did you get that, Erica? Sure, that's fine, no problem. It's one of these ones that you sort of see in the textbooks, it gets bandied about, but the green is from the chlorine and the yellows. It's supposed to be a bright yellow. It's difficult trying to get the right colours to represent the actual balls. I should have probably held up all the models in front of you. Yeah, that's sodium chloride because they're ionically bonded. So we've got chloride ions and sodium ions there. So because there's so many of them, we only show the formula as being the ratio, hence why one chlorine and one sodium when they're actually in the formula, NaCl, because that's the ratio, it's a 1-to-1 ratio. Well done, Kaylee. Right, four then. What's four going to be? This one you should know. Yep, well done. It is good old water, the H2O. If you'd put dihydrogen oxide, that would also be technically correct because, of course, with a lot of these things, we've got the name that we use, but then there's the actual chemical name. So if we think back to methane, when we look at methane, we've got four hydrogens around a carbon. So you could turn and go, okay, we call it methane, but is there another version? And anything it's four is a tetra prefix. The same with like the ammonia, we could say that's trihydrogen nitride. Yeah, well done, Erica. So it is. It's the water for the H2O. I am going to be really mean though, because I've just seen your H2O is lowercase h and lowercase o. Where you've written it down, and we'll go for what you've got on your paper rather than what you put onto the chat. If you've got the element as a capital letter, and if it's got two letters, obviously the second one lowercase, like the sodium chloride. If you've got them written correctly, you can have them marked for the molecular formula. But if you've used a lowercase, we're not going to give you the mark. We're going to be really, really, or I'm going to be really, really picky, I think, today. Because obviously we're looking at preparing for the A level. Now, at GCSE, had you written lowercase for H2O, then that would have been no, actually, we can't give you that. You're allowed to get it wrong once, as soon as you get it right another time. You go, yeah, okay, we'll accept it. At Key Stage 3, we'll give you a bit of leeway. At A level, no, you've got to make sure we have those capital letters and that all elements are written correctly. So I am going to be quite mean there. Five. What is number five? Get that popped into chat. Awesome. Well done, Erica. And this is where it's like, how quickly can I type? So yeah, well done, Kaylee. So I think those first five are sort of the easier ones. Maybe, I don't know how you feel, but let's go on to six. What's six all about? Yeah, you need to have confidence, Kaylee. It's diamond, absolutely. And I like the fact that you've just put the carbon. because diamond, is an allotrope of the carbon, because carbon exists in so many different ways. Yeah, and that's the key thing, Erica. It's one of these weird things. We just go, hang on, there's a load of carbons. How am I going to write the formula for that? But because it is only actually one type of atom that makes up the structure, it is just C. It's just a capital C. There's just loads of them that make the actual diamond structure. So it's one of the weird things. We go, what's the molecular formula for diamond? It's just C. There's just plenty of them. But well done, Kaylee. That's a really sort of the tricky one there, that I thought, yeah, I'm sure people know it's diamond, but will they be able to cotton on to the fact that it's just one type of atom, in which case you only write down the symbol for that particular element. Well done. Right, 7. What is this one? This is going to be chat silence of, I don't know, I'm not sure what 7 is. What were your guesses? That's all right, Kaylee. It's one of these ones I thought, oh, if I tell you what the actual colour stands for, just going to totally give it away. If you think back to number 3, and obviously that was sodium chloride, then I know I couldn't get pictures where the colours were exactly the same. This is the challenge, that's supposed to be the same colour, green. That might help you a little bit on that front. So 3 was sodium chloride, 7 must just be yeah, I'm not sure about the U, but yeah, definitely chlorine. So sometimes, we can have these molecules and they're diatomic. You have 2 of the atoms make up that particular element, because that's how they go around. Yeah, that's it, Erica, absolutely. You put C2, my lovely, but Cl2. So I'm sure you've got it written down on your bit of paper as Cl. Otherwise, that's like, no, that would be 2 carbons. So yeah, that was just a diatomic molecule of chlorine. Cl2. Right, 8. My favourite one, because when you have the right orientation, it's like a little doggy. It's the cute one of all of all different ones. That's all right, not a problem, Erica. Yeah, fab. Well done, Kaylee. Ethanol. So number 8 is ethanol, and you can see there you've got the red bit and the white of the actual alcohol group. So it is, when you come to do these ones and the actual formula, it's just counting up the numbers of what you see. So C2H6O. If you'd typed in C2H5OH, I would also accept that as well, because the OH group stands for the alcohol part of it. So yeah, well done. That's awesome, Kaylee. Right, 9, tricky. See, these last 3, really quite challenging. So number 9 is, what do you reckon? Or at least the molecular formula. Because sometimes seeing it, you go, oh yeah, okay, I've got the molecular formula. I haven't got a clue what it's called. So what do you think 9 is? Based on the fact the yellow is a sulfur. Hopefully you've already figured out what the red ones are and there's the white ones, in which case you can type in the formula. And then once you start typing the formula, you might go, oh, yeah, that's what it is. Any thoughts? It's going to be chat silence, isn't it? No idea. Right, if we start off, obviously we've got hydrogens, we've got 2 of them. We've got 1 sulfur and we've got 4 oxygens. So if we put them in that order, our formula is H2SO4. So that's the molecular formula, H2SO4. Now that might have you going, oh, that sounds familiar. I'm sort of getting my head around that. Any thoughts now? I've said the formula. H2SO4 is Sulfuric acid. Yeah, well done, Erica. Fab. And that's the thing, sometimes it is just thinking, oh God, that just looks awful. It's just a molecule. I haven't got a clue. Because, of course, when we talk about sulfuric acid, I do say we don't ever draw it out like that. We just talk about it in terms of it's an acid, here's the formula. But you've probably never seen it drawn out or seen it in that format ever before. And this is something that certainly, we expend upon at A level, and we do look at these things and go, well, you've been talking about it for a long time. Here's actually what it looks like. This is what that molecule is. So that is sulfuric acid. And of course, that molecule would float around in a load of water. Well, I don't know, Cal. That was a real toughie, that one. Right, 10. What is this one? Again, hopefully you might have been able to work out what the formula is. And then maybe once you've got the formula, then you'd be able to work out the name. If you didn't know the formula, then I don't think there's actually any way you could work out the name. Any thoughts on this one? We've got some carbons in there, we've got some oxygens, and we've got some hydrogens. So again, it's an organic molecule. Yeah, well done, Kaylee. So with questions like this, it literally count the actual particles up and go, yep, 6 carbons, so C6, 12 lots of the white hydrogen, so H12, and then O6. So Kaylee, C6H12O6, or Erica even for that matter, what is C6H12O6? One of those ones that we literally sort of cram into your head all the time. So C6H12O6, what is it going to be? It is. Yeah, absolutely. That's glucose. And again, it's one of those things, isn't it, that we've been running glucose down, literally, obviously, we've been eating it since you were born. But we've been talking about glucose since year 7 when we talk about photosynthesis and we talk about respiration. But never before have we actually popped that molecule in front of you looking like that. We draw it in slightly different ways in biology, and certainly in chemistry, we just use the formula or put the name up. So seeing it as a diagram, as actually, here's your monomer picture, here's what the model looks like. Yeah, that's quite a new thing, but this is what hopefully you'll get used to as we go through. And certainly one thing we encourage at A level is that if you're not sure of something, then there's ways of finding it out. So if you think about it, actually having something in front of you to model does actually help with understanding. Right, I'm just going to flick to the next slide, and then these are all going to pop up. I've put them in slightly, I've got the order wrong there. I don't know what was going on when I obviously did this presentation, but I number 3 and number 4 around. But as you can see, we got them all there. Right, so it's out of 20. So you can only get the mark for the molecular formula if you've got the capital letters in the right place, or in the case of this sodium chloride, the lowercase letters in the right place. So 1 mark for the name, 1 mark for the formula. So give yourself a score, ladies, out of 20. So what's it going to be? Pop it into chat. We've had a range of things from 10 right up to 20 in the last lesson. So let's see if yours is somewhere in that range as well. Scores on the doors, ladies. Awesome. Well done, okay, that's great. Come on, Kaylee. Add them up. What is it going to be? I should perhaps do a drum roll here, shouldn't I? You don't know? Okay, do you know what? I'd have to scroll through the whole of the chat, won't I, to be able to have a look. Not sure if it's 16. On this occasion, I'm not even going to go through chat. I'm just going to say, we'll take your 16 as an okay on that front, and just go, well done, both of you. Oh, bless you. I think you've both been doing really well. Just looking through the chat, you've got some great stuff there. So you've definitely both, well into double figures. So yeah, that is awesome. That is a really good start to this. So you should be pretty proud of yourself, because remember, you haven't actually done science now for quite a few weeks. It's really easy, just as to say, if you don't use it, you lose it. And that is key with everything. And this, obviously, the years that we've had as well, it's very difficult, isn't it? But I think you've both done awesomely well there, so you should be pretty chuffed. Right, just going on to this next bit, just to see and give you a bit of a feel for the sort of questions and things that we'll be looking at more so. And I say, you're going to have to learn to love your mold. And it isn't going to be the little fairy creatures, unfortunately. It is going to be our actual equations. So we're just going to have a look at this particular example. We're just going to work through it together and just see if you, as we're working through it, if you can actually get an idea and develop. Now, I'm going to write onto the screen. Now, I don't know if you can see this. If I put a squiggly little line underneath that answer bit, can you see that? Because I've had some people say, yes, they can. Some people say, no, they can't see the red sort of annotation that I've just done. So if you can see the red annotation, awesome, because that is going to make life easier. If you can't, then oh, you can't, right, okay, and you can't either. Okie dokie then. So we're going to have to talk through this one because it's not going to want to show it to you. So with this first question, and I know we've only got literally 4 minutes to whiz through it, we're going to be having questions like the ones up here. How many was the calcium chloride I produced in 10 grams of calcium carbonate? Now, what I was hopefully going to do is be able to draw on the screen in front of you the fact that we've got 2 lots of hydrochloric acid are going to react with 1 lot of calcium carbonate. And we're going to make 1 lot of calcium chloride. We will make 1 lot of water. Oh, there's a lowercase there, that shouldn't work. And we will also make, she says, 1 lot of carbon dioxide. So given that information that I'm just popping into the chat, if we had 10 grams of calcium carbonate, how much calcium chloride would we make? And therefore, how many moles of calcium chloride would we make? So we've got to think about how would you do that. So these are the sort of questions we're going to come up against. So we're just going to talk through it just so you can, again, get that idea. So what we have to do, exactly the same as what we've done at GCSE, is we look at the equation. The first thing we always do is to write down the equation and make sure it's balanced. And then the second thing we can do is, right, what do I need to know? So I want to know the moles of my calcium chloride. I need to figure out, things about my calcium carbonate. The rest of it, we're not worried about. So we look at the calcium carbonate, we look at the calcium chloride and go, okay, let's work out how many, what the mass is. So the key thing to do in this is I've got to find out, using this equation, moles equals mass over relative molecular mass. So I know the mass of calcium carbonate is 10 grams. I can work out my relative molecular mass by adding the mass of calcium, of carbon, and of 3 lots of oxygen together, because that gives me 100. So I've now got a mass of 10 divided by a relative molecular mass of 100. And that gives me 0.1 moles. So this is where the little fairy creature comes in. If I've got 0.1 moles, I know from my equation that if I've got 1 lot on that side and I've got 1 lot on that side, then I must have 0.1 moles of my calcium chloride. So now if I've got 0.1 moles of my calcium chloride, I can work out my molecular mass. And that's 111. 1 lot of calcium is 40. And then obviously chlorine is 35.5. So 2 lots of those adds up to 111. So now I go, right, I've got 111 and I'm going to times that by 0.1. So timesing that by 0.1 is going to give me a mass of 11.1 grams. So I've got 0.1 moles and I've got 11.1 grams made. So we're going to be using these equations and doing more of it. You've seen these before, so this sort of gives you an idea of where we're starting from. In terms of how many molecules are there in that mass, hopefully can you remember hearing the name of Amadeo Avogadro, and we had Avogadro's number? Well, once we know moles, we've got this N part of it, so our 0.1 moles, we can then turn and go, yeah, multiply that by Avogadro's, 6.02 times 10 to the 23. And that will tell us how many actual particles we've got, how many atoms have we got. So again, you have looked at these in your GCSE before, and we could do more of this in A-level. And then atom economy, again, something we've come across. Out of our equation, if we've got a total mass that we put in of 173, how much of it was useful? Well, if 111 out of 173% of it was useful, that's going to give us a percentage of atom economy to be 64%. So all of these things, as you can see just from talking through, hopefully going, yeah, we've come across questions like that at GCSE. And they were the higher level questions in that particular topic. But this is what we're going to be doing a lot more at A level, and particularly in the first couple of months when we come back in September. So hopefully that gives you an idea of, we're just expanding on what we know. We're building on what we already know. We're adding some more knowledge to it, but we already have that really good scaffolding and that basis there. So hopefully you feel a little bit happier about what we're going to be looking at. If there's any questions that you've got, pop it into chat now. Or if you want to unmute yourself, then that's absolutely fine. But hopefully, you'll be going, yeah, actually, chemistry can be pretty good fun. I think I'm going to enjoy it. And hopefully the pair of you will be turning up in September, raring to go, ready to have a good couple of years in chemistry. So if you have got questions, pop them in now. If you haven't, then thank you very much for turning up, ladies. Hopefully it's been useful to you. And take care, have a lovely summer, and I'll see you in September. Take care, Oka. See you soon. Bye-bye. Take care, Kaylee. Have a lovely summer. And I'll see you both September. Take care then.